Hey everyone, welcome to this explainer. Today we're tearing down the curtain on how top-tier motion designers build those impossibly complex animations using just a few incredibly simple tools. You know the ones, those high-end commercial spots or sleek cinematic UIs with hundreds of perfectly synchronized moving parts. Yeah, we're going to look at exactly how they do that. We're about to fundamentally change how you approach building systems in your timeline. Getting this specific architectural approach down is an absolute game changer. We're talking lightning-fast editing, zero-stress client revisions, and super quick render times. So let's jump right in, because the real secret isn't quite what you might think. I literally love this quote from Design Kakashi Studio. Top-tier motion designers don't rely on expensive plugins. They master the add menu. It's so easy to fall into that trap, right? Thinking you've got to buy endless, heavy third-party plugins just to get a pro look. But the actual secret to high-end, fully editable, and beautifully optimized stuff is hiding right there in plain sight, inside the native Shape Layers add menu. It's a total goldmine. Instead of bogging down your machine with heavy effects that take hours to render, we're going to see how stacking basic native vector operators creates results that look wildly complex, but architecturally, they're remarkably simple and mathematically flawless. Here's what's on the agenda today. We'll kick things off with pucker and bloat morphing, then master trim paths, move on to repeaters and radial bursts, and wrap it all up with the generative engine. Okay, let's dive into our first topic, pucker and bloat morphing. This is honestly one of the most fun ways to instantly manipulate the vertices and segments of basic shapes. Zero manual pen tool wrangling required. It basically runs on a single slider, but getting a feel for the two distinct directions is the real trick here, because it completely rewrites the vector math. If you drag those values into the negative, you get a pucker. This literally pulls the vertices outward while sharply curving the path segments inward. You end up with these super spiky, intense star shapes. But slide over into the positive values and you get a bloat. This pulls vertices inward and balloons the segments outward, giving you smooth, rounded, clover-like designs. You can warp a basic primitive into something entirely new in literally milliseconds. Oh, and a quick tip. Hold Shift while dragging to jump to those crazy extremes, or use Command or Control for the fine-tuning. Let's look at a practical workflow. Say you need a custom floral graphic for a client. Please do not draw that by hand petal by petal. Here's the smarter way. First, just draw a basic polygon. Then, pop open that Add menu, toss in pucker and bloat, and set the bloat to a positive 15. Next, jump into your polygon path settings and crank the points up to 10. Finally, dip that outer roundness to negative 50% and tweak your radius. Boom. Just like that, your standard, kind of boring polygon is a completely custom flower graphic. And the kicker? It's fully editable. Client wants 12 petals instead of 10? No sweat. You just type a 12 into the points box. You're changing a number, not redrawing a whole shape. Moving right along to our next section, let's master trim paths. We're shifting gears from transforming static shapes to injecting some dynamic, flowing motion. We're talking about the absolute workhorse behind those modern drawn and reveal animations you see everywhere. Now, if you're animating UI outlines or complex charts, you might instinctively reach for traditional masks. Seriously, don't. Trim paths is the mathematically precise way to go. It's a live path operation that animates the start, end, and offset properties of a stroke. It seamlessly draws a line on or erases it over time. But the real magic isn't just sliding from 0 to 100, it's all about mastering the timing relationship between those start and end parameters. How you sequence these keyframes is exactly how you pull off that highly requested shooting star or laser effect. Let's break it down. First, keyframe your end property from 0 to 100%. This makes the line draw outward. Step 2 is the secret sauce. Move forward a bit and keyframe the start property from 0 to 100%. By doing this, the tail of the line is actually erasing itself while chasing the head. And why offset this by exactly 5 to 10 frames? Well, that gap dictates the length and speed of the star's tail. A tight gap gives you a tiny, rapid bullet. A wider gap, you get a long, trailing comet. Finally, hit it with a strong ease in and ease out in the graph editor. Suddenly, you've got this brilliant streak of light whipping through the frame. Now, when you've got multiple shapes trimming inside a single group, there's this tiny drop-down that totally separates the amateurs from the pros. You absolutely need to understand the difference between simultaneous and individual behavior. If it's set to simultaneously, every path in your group draws on at the exact same time. This is awesome for explosive bursts or like a complex neon sign powering on, but slip that switch to individually and the whole game changes into a relay race. One path completely finishes drawing before the next one even starts. This is perfect for step-by-step infographic reveals or really elegant logo builds where you purposefully want to guide the viewer's eye. If you ignore this dropdown, you're just going to be fighting the software instead of letting it do the heavy lifting.
All right, let's step it up. Section 3, repeaters and radial bursts. This is the ultimate multiplier. This is where your animations go from simple to cinematic. So what's a repeater? It's a procedural operation that pumps out virtual copies of your base shape, applying a specific mathematical transformation to every sequential copy. Put simply, it takes that one animated line, like our shooting star, and explodes it into a massive complex system. You animate one single thing, and the repeater does all the heavy lifting to turn it into 100 perfectly synced elements. Work smarter, not harder, right?
Let's build a classic radial burst. You know, the kind you see in fireworks or slick high-tech UIs. The workflow is seamless. First, you draw a thin vertical line and give it a quick trim paths reveal. Second, you toss on a repeater and bump the copies up to 12. Third, you reset the repeater's position transform. Lastly, you set the repeater's rotation to 30 degrees. Okay, pause. Pay close attention to the math here. Why exactly 30 degrees? Well, a full circle is 360 degrees, right? 360 divided by our 12 copies equals exactly 30. Using this specific math guarantees a perfectly distributed cinematic burst every single time. Actually, hold on. I need to flag a massive trap right here. This is literally the #1 mistake designers make when building these radial bursts. By default, when you add a repeater, the software automatically shifts the X position to 100 pixels to spread copies out horizontally. If you're going for a circular burst and you forget to reset that group transform position to 0,0 before applying the rotation, your radial axis is going to completely break. Instead of a nice, neat circle, your shapes will spin off into this wild, uncontrollable, chaotic spiral. It's an absolute mess. Always, always, always set that position to 0,0 first. That coordinate is your best friend. Finally, let's wrap up with Section 4, the generative engine. Let's look at the big picture. Stacking all these operators essentially turns your timeline into a generative motion graphics engine. You aren't just slapping on isolated effects anymore, you're engineering a robust system. Think about it. You start with a base shape, morph it mathematically with pucker and bloat, then pipe that into trim paths for some dynamic draw-on motion. Then feed that whole moving setup into a repeater to duplicate it perfectly around 360 degrees. And the real pros? They'll link that rotation math with a quick expression so it auto-updates. Client wants 17 copies instead of 12? You change one number, and the math handles the rest. By combining these simple, native tools, a basic line becomes an impossibly complex, fully editable architectural masterpiece. And because it's all native vector math, your render times are virtually zero. So I'll leave you with this to chew on. How are you going to combine these operators in the Add menu to build your own generative animation engine in your next project? As you dive back into your work today, remember that the Add menu isn't just a basic list of tools. It's a playground for procedural design. Go stack them, mess with the math, and see what happy accidents you can create. Thanks for hanging out with me for this explainer, and I seriously can't wait to see the intricate systems you come up with.